Okay, LeetCode problem 111. We're going to find the minimum depth of a binary tree. So given a binary tree, find its minimum depth, and the minimum depth is the number of nodes along the shortest path from the root node down to the nearest leaf node. In other words, the shortest path to get to a node that has no other children. So it would be here, because we have 1, depth of 1, 2, or I guess, let's see, yeah, so it's 2, so we're counting that root node, so we'll need to add 1 to our return values for each tree to count that root node. And as we're recursively calling it, adding that 1 will increment as we backtrack up the tree. So I'm going to do this 2 different ways. I'll create a depth first search method. So let DFS, and then our first, we'll check our base case, which if there is no node, return, let's see, is return 0. So if there's no value for our node, we can just return 0 for it, because there's no depth. And then we need to check if our left node, so if our left tree is null, return 1 to DFS node.right. So if we don't have a left tree, or we can just immediately start recursively calling the right side, and then else if node.right return DFS node.left. And if our right tree is null, we can go ahead and recurse that left side. And then, return 1 plus that dot min DFS left. So here, we're checking if our left node, left node is null, then we'll go ahead and traverse the right, and if right node is null, we'll traverse the left. Else, if neither of them are null, neither right or left node is null, we can get the minimum depth that's returned from either our left tree or our right tree, and we'll return 1 to it. So let's see. Oh, I need to call that DFS function. So DFS, that should work. And it does. Okay. And then there's another way I want to do this, which makes a little more sense, but we have to use an infinity assignment to our nodes. So I'll go ahead and check if, let's see how I do this. If not, okay, so here we're just checking if there's no left or right nodes. So there's no child nodes. We've reached a leaf node. We can go and return 1 because there's nothing else to check. And then let's see. And then 1 plus left depth. We can, let's see. Left depth, okay, yeah. Depth equals. So if we have a left, we can do this. Left, else, infinity. So what this does is, if we So first we check if there is anything to check. We'll return 0 if not. That base case probably won't hit. And then we check our left and right nodes. If there are none, that means we've hit a leaf node, and we can return 1 for just that value of depth. And then we'll traverse our left and right. So if we have a left node, then we can traverse the left side. And if there is no left node, then we won't get that minimum value. So we can just assign it infinity, which isn't, I guess, the ideal way to do things, but it does run faster. So I can submit this and see, yeah, it beats 56, and I think the other way only beat about 30% of run times.